Tron light bike. So if you guys recently saw the remake of the movie Tron, we thought it was cool, so we wanted to take a page out of their book and try to create the light bike. So just to start off, obviously, as you see up on the screen is our CAD model. We have three basic pieces for the body: the left piece, the right piece, and this little cover, the transparent cover on top. The vast majority, almost all of the geometry you see for the main body is created entirely out of boundary bends and thickens and solidifies. So getting those to work was a big challenge, especially when you have this many boundary blends in conjunction with one another, trying to get it all to thicken out to have that minimum thickness of like 0.15 inches to have some structural rigidity. We just ran into a ton of problems there because it would try to run into one another, and so that was a big challenge as we were making it. We also have our purchase parts included in there as well that we, for almost all of them, we had to model ourselves. So here's our inside. So we have our screws. We have our left and right side attached. These screws you can see protruding here. So we have our motor here, which is connected by our O-ring, our belt, to our back axle here. Is connected to our second half of that pulley, which is connected to that wheel. Our 9-volt battery here with a clip on the end, which will power our motor via this switch that can actuate back and forth. There's better stuff coming up. So I can run the motor for you too. So obviously that was pretty quick. So let's try to get a better view for you guys. So there's our motor going. You can see as the motor rotates, it rotates this back wheel. We also, in our physical model, which Eric will talk about here in a second, we have LED lights here in the bottom section and in the top section to give it kind of that illumination you see in the movie Tron on the light bike itself, as well as, if I bring back the top cover, we have our top cover not screwed down, but held down by this magnet you see here, as well as this magnet here, this red piece, so that it's easily to get in there and change that 9-volt battery if and when it does run out on you, just to make it easier for the user.
Okay. So we'll now move on to our physical model, which is here. It turned out really well. We were pretty pleased with it. Like Derek said, this is pretty much all made with boundary blend, so it's just extremely complex. This back surface, just to like color it black on here, we had to click like 1,000 different surfaces. Like, it was a pain, but it worked out really well. One of the things that we wanted to do was we thought it would be cool to kind of showcase the SLA material. So to do that, we put LEDs inside, and we used the clarity of the SLA material to show those LEDs. So places that we didn't want illuminated, we painted with black, white, and red. And places that we did want illuminated, we left clear. So as you can see, when we turn this on, the top and the bottom of the bike lights up, as well as the wheel moving. One of the issues that we ran into when we built this is, honestly, when we built it, we thought that we'd have issues with the pulley system. We have a pulley system, as Derek showed you. We thought that we'd have issues with those pulleys slipping on the axles, and what actually ended up happening is the O-ring that we use slips on the pulleys. So the pulleys don't slip on the axles, but on a regular straight line, it doesn't push it forward just because there's too much friction on the front wheel. We weren't actually planning that. Also, when we put these LEDs in, they said that they needed a voltage drop between 1.9 and 2.4 volts. So using a 9-volt battery, we assumed that you could put 4 of them in series and get a 2.25 voltage drop across them. And evidently, when you put 4 LEDs in series, it like amplifies the resistance in them. They like exponentially go up, so you can't put 4 in series. So once we put the whole thing together, and being the smart engineers that we did, we put the whole thing together before we tested it, and we had to pull it all back apart because you have to actually put 2 in series and then put 2 in parallel and run a resistor with them to make it work. So that was kind of a pain. Another cool thing that we did is we use these circular neodymium magnets, and if you ever put 2 of those together, they're insanely hard to pull apart. So what we did is we actually left SLA material between the magnet and the 2 magnets, so it's like it won't fall off, but it's really easy to pull off. So it's really easy to change the magnet, but it's not going to fall off on you. It's kind of cool. I thought it turned out really well. So once again, there's our model. I guess that's it.
Yeah.